There you go. I think you heard that. Yeah. So this is for Gabi's reference. So we're going to start the summer work as of today properly. So there's two things we want to do with the summer work. One is we just want to make sure that all the things we are good at, we stay good at. We don't let our sharp skills go blunt. And the second thing is just that we are ready for what is coming next year. So both you and Gabi have already done some work on logarithms. I think you're both getting your teeth into that. You're starting to see that although they're strange, they do follow rules. You get used to the rules, and eventually you get so used to them that you don't think about them anymore. And that happens with a lot of maths. We're not going to do any logarithms today. We're going to go back to quadratic equations. All right. So first things first, why do we study quadratic equations? I know you've already done some work on them. Could you explain in your own words why we study quadratic equations?
It's a good tool to like practice all the algebra we've learned, and it can help us look at optimum prices if you're looking at it from an economics perspective.
Good,
and
yeah,
stuff like that.
Yeah, so they're the first kind of functions that you learn that have a maximum or a minimum, right? Because before we've just been dealing with linear equations, which are just straight lines. Okay? So they're quite good for modeling anything that increases up to a point and then goes down, or decreases up to a point and then goes back up. They're quite useful. So that's really good that you've taken in the major lesson from your coursework. I would say another good reason is because they are the first non-trivial kind of equation that you have to solve. Okay, in the linear equations, once you learn how to solve them, linear equations always have one solution. Okay, and that's all there is to it, basically. Whereas these ones, you have to learn a bit more of an in-depth method. But I would say, in general, we need to understand where quadratic equations come up. So the general form of any quadratic equation is some lot of x squared, which we denote by ax squared, plus bx plus c equals 0. Okay. Now, does that mean that all quadratic equations look like this? No, but they can all be rearranged into this form, one way or another. Okay, so when I write this, even though it looks very, very specific, it's actually totally general. So the important thing here is that the unknown is squared, and that's the highest power. So any time when an unknown value is being multiplied by itself, or some part of itself, you will get a quadratic equation. All right, so I want to give you a couple of examples. Let me give you the classic example is when you are given the area of something. You're given the area, and then you're told something about the sides. Basically, like the sides, I don't know, like x plus 3, x minus 2. And can you see, to work out the area, you end up having to multiply the two sides. Right, like that's the classic case. So you should understand, and multiplication turns up quite a lot in mathematics. I'm sure you've noticed that by now, right? So anytime where the unknown gets multiplied by itself, you're going to get a quadratic equation. All right. Typically, these turn up in areas. Also turns up in kinetic energy, half mv squared. I don't know, equals mc squared. That's another good example. Yeah, what are some other half at squared as well? That's another equation from physics. Many times where something turns up squared. Right. So we've got to learn how to solve this. So let's go through some of the most basic ways to solve them. So the first way is by factorization. I'm sure you're quite familiar with this by now, but let's go through an example together. Could you try to solve this first, just using
Yeah. Can I do it
factorization?
on my, do you want me to do it on here or should I do it on my iPad?
I think you can do it on your iPad.
Okay. Great. Okay.
Okay, what did you get?
Like the solutions for the quadratics would be 4 and -7.
Good. Yeah,
Oh, well, in brackets, it would be -4 and
exactly. Yes,
+7.
it's -4 plus 7, and therefore x must be -7. Okay, cool. So that's the basic idea. Oh, hello, little one. Come here. No, 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 come. Wait, wait, wait. Do you wanna have a look at Iris quickly? Okay.
Yeah.
Yeah. There we go. Hello. Hey, there we go. Can you do quadratic equations yet, Iris? No, I think it's a little bit beyond her. Okay, say bye-bye to Olive. Bye-bye. Say mama. Oh, she doesn't look happy. Anyway, okay, so let's have a look
She's so
at.
cute.
Pardon?
I just said she's so cute.
Oh, she isn't she? All right, shall we have a look at the PDF that I
Yeah.
sent you? Um, so have a go at the first questions.
Oh, I did some because I thought you wanted me to.
Awesome, great. Okay, cool. Yeah, so just
No,
just so
not
you know,
all of
like
them.
I'm perfectly happy to do this either way. Okay, so did you solve the which ones did you do?
Um, where A equals 1, I did the first 4, but I didn't do the fifth one.
Okay, so
And then,
let's talk. So
yeah.
for the benefit of Gabby,
Mm.
if you are watching Gabby, let's have a look at question 3 and question 4 and question 5 because I think those are the interesting ones. All right. So question
Oh, wait.
3 is this one.
Yeah, I think I did. Yeah, I did 4 wrong. I didn't read it properly.
Okay,
No,
well, we'll get over it now. Okay, so let's have a look at this one. Now, how can we factorize this? We need two numbers that add to make 6, but multiply to make 9. What are those numbers?
3 and 3.
3 and 3. So we get x plus 3. and x plus 3. Some places you'll just see this written as x plus 3 in brackets all squared. We'll just write it that way. And then, of course, the solution is just x equals negative 3. All right, so that's question 3. It just has one real solution. Now, let's have a look at question 4. So I deliberately put this in. So question 4, I'm going to keep this. I'm going to rub out the solutions here. But we should remember what the solution to this one. Now, question 4 is this, if I'm not mistaken. X squared plus 7x plus 10 equals x plus 1, right?
Yep.
Now, remember, before we can solve this, we need to move everything over to one side, usually the left-hand side. So we subtract x from both sides and we subtract 1 from both sides. And then what are we left with?
X squared plus 6x plus 9.
Now, have we ever seen this question before?
No.
I think we have. It's the question we did before.
Oh,
Can
I
you
thought
see
you meant
it?
with the
Oh, sorry, as in, yeah. So the idea is when you rearrange it, when you tidy it up a bit, it just becomes a problem before. Therefore, you don't need to do any more work. Don't do any more work than you have to in mathematics. So just keep an eye out for when things simplify to problems you already know how to solve. It's really important to keep this big picture view on when you're doing maths, because you get some students who are really, really hard working, really, really diligent. They try to do it every step and they don't see, this is just the same as this one, or it's really similar to that one. I just need to change these things. And only when you take the big picture, you get it. Okay, so question 4, I put in just deliberately to show you this is the same as question 3, just cosmetic differences. Now, question 5, have you had a go at it yet?
No, not a good one.
Okay, so you want to have a go at trying to solve this one?
Well, I just don't know how you simplify it.
Yeah. So this does not look like a quadratic, does it?
No.
So one of the big things that makes it not look like a quadratic is the fact that the unknown is on the numerator. Sorry, on the denominator. Therefore, what do you think we have to do? Probably get rid of the denominator. So what do we do? What do we multiply both sides by?
The denominator.
Well, we can't multiply the denominator. All we can do is multiply both sides. If we multiply up by the denominator, sorry, I don't know if that's what you meant. So we're going to multiply both sides by x plus 1.
Yeah.
Now, what happens on the left-hand side first?
You get rid of the fraction.
Exactly, right. They cancel, and we're just left with that. Now, this looks pretty good, right? This looks like a lot like a normal quadratic, right? We got something factorized. The problem is it doesn't equal 0. That's the problem. So now what we need to do is you need to expand out these brackets and then rearrange it. So probably actually the first thing that I would do, this is one of the nice things about Zoom, is I can just flip all this stuff around. Just going to move everything like that. Yeah, I just like having everything. Oh, okay, I should not have done that. That was question 2. One of the things, yeah, there we go. I just like always having x on the left-hand side. Now, we're going to expand out this bracket. Could you have a go at that, please?
Yeah. X squared plus X minus 2,
Mm-hmm.
I think.
X squared plus X minus 2. Good. Now we're almost
How
there.
did you get X plus 2? Because I thought we were multiplying it by X plus 1. Like when you
Yeah,
simplified it.
yeah, thank you. I don't know where that came from. Thank you.
Oh.
Sorry, it should be that. Sorry.
That's fine.
So now, sorry, when you expand this
Yes.
out, you should just get X squared minus 1. I do apologize.
No, that's fine.
Now, this becomes very, very straightforward. You just bring the 8 over. You get X squared minus 9 equals 0. And then you get X plus 3, X minus 3. Equals 0, and therefore X is either 3 or minus 3. Okay? So that's how to solve this, but there's so many ways that you can disguise a quadratic equation. So this is something really, really important to think about. And maybe I'll give you some more problems on this, just like one every single week, just so you get used to them. But it's not always obvious whether something is a quadratic equation. However, I would say that if you have things like the unknown on the denominator, it's usually a nightmare to deal with. So if you start multiplying up by denominators, then I think you will find they become quadratics. This is another good example. Okay, let me give you this example. Imagine we have 5 divided by x plus 3. And then we're going to do, let's say, plus x divided, 8 divided by x plus 1. So this would be, no, not plus 1. Okay, does this look like a quadratic again to you?
No.
No, okay. There's no hint that it's a quadratic in terms of there's nothing being squared. However, if you multiply up by the denominators, you will see how this becomes a quadratic. All right, so do this step by step. First, multiply it by x plus 3, and then multiply it by x plus 2.
Wait, but can I multiply each fraction by their own denominator? Like, do I have to do both?
You have to remember you multiply the sides of an equation. Okay, so you're going to have to multiply all of it first, either by x plus 3 or by x plus 2. It doesn't matter. Okay, or you can multiply them by both at the same time. It's totally up to you.
Okay. But then when say if I am multiplying 8 over x plus 2 by x plus 3,
Yeah.
then would it become like 8 over x plus 3 times x plus 2?
It would become this. Okay, so if we multiply everything by x plus 3, It's going to become this.
Yeah.
Um,
Okay.
can you see it? So it just cancels the denominator on the right, on the left, sorry, on that 5. Okay. Can you see everything here has been multiplied by x plus 3? Then you just go and do the same thing with x plus 2.
Okay. So then it's okay. So then you have 5 times x plus 2 plus 8 x plus 3, and then equals 3x plus 3 times x plus 2.
Okay, good.
And then do we expand it out?
Then you have to do a load of expanding. So eventually this turns into all of this. I think it's really important to get a feel for how this is, so how the denominators move around and how they pop up again. So can you see that they've both popped up on the right? And then there's where there was a divided by x plus 3 on that 5, it's now been replaced by multiplied by x plus 2. And then the other way around on the 8, it was divided by x plus 2, now it's been multiplied by x plus 3. It's just kind of like switching around. Once you get a feeling for how these things move up and move around, then you start to see a lot of these basic steps of algebra as like this moving around and rejiggling, and it becomes very, very visual. And once it becomes very visual, once you start thinking about moving things from the bottom to the top, or things cancelling out, and just once it becomes visual, you actually become very good at it, because your visual sense is probably much better than our kind of like abstract reasoning sense. Okay. Anyway, now you've got these, then you have a lot of expanding out to do, which I suggest you do very slowly and very carefully. And then you need to move everything over so that you have a quadratic equation.
Okay. And for the right hand side, can I multiply the brackets by 3 first, and then multiply the brackets by each other?
Well, when you say multiply the brackets, really the 3 would just be multiplied by one of them. It doesn't get multiplied by 2 of them. It gets multiplied by one of them. The 3 will just apply to whichever one you choose. But my recommendation would be that you multiply the brackets first. So do what's inside the square brackets, then multiply everything by 3, because then it's easier to keep things tidy.
Okay. Got it. Okay. I got negative 3x squared minus 2x plus 16 equals 0.
Okay, so minus 3x squared.
Yeah.
Right. The reason I know that can't be correct is because if you're expanding this out, if we just look at the x's on the left-hand side, you should have, oh no, sorry, minus 3x squared. No, sorry, you're right. Sorry. So let's just expand this out. Plus 10, plus 8x, plus 24. Yeah, that's all correct. And then this should have been 3x squared.
Yep.
3x squared plus 15x, right?
Plus 18.
Yeah, plus 18. Okay, so generally, what I find is it's easier to do. Like you don't want to be dealing with negatives on as a. Okay, so what I will actually do is just flip these two around. Can you see it? So I'm just going to swap the left and right. And now I take 5x from both sides. So, sorry, I take 13x from both sides, so I get 2x. And then I'm going to take away 34 from both sides, so I'm going to get 16. Negative 16. Okay. Now, how are we going to deal with this? This equation here, 3x squared plus 2x minus 16.
Completing the square.
Yeah, we could complete the square on it. We could use the quadratic formula. We could try and factorize it. It's totally up to you. Doesn't matter.
Wait, my negatives are different to yours though. Is that because you flipped it around?
Yeah, so what you should find is that all my negatives are positive. Sorry, all your negatives are now positive and all your positives are now negative.
Okay.
Yeah?
Yeah, but just because I have negative 3x squared and negative 2x and
Plus
positive
16.
16.
Yeah, exactly. So
Yeah.
if you just multiply everything by negative 1, then you'll be fine.
Okay. Wait, can you factorize this?
You can, but it's not easy.
Okay. Yeah. struggling to factorize it.
Okay. So why don't you just use the either completing the square or the quadratic formula first. Once you have a solution, then I'll show you how you can get there via factorization as well.
Okay. Okay. I got -2 for one of the answers.
Yeah, -2 is one of the solutions. Oh wait, -2? I think it should be +2 actually.
Because if I use the quadratic formula, it's -2 plus or minus -10/6.
No, it can't be. It's got to be wait, plus or minus -10. It can't be a negative in the square root. It's got to be plus or minus 10. Let's have a look at this. So 3x squared plus 2x minus 16 equals 0. So let's use the quadratic formula. So you get -2 plus or minus the square root of 4ac. So it'd be 4 times 4 times 3 times -16. So because negative, it cancels out, it's going to be positive. 3 times 16 is 48 times by 4. is 190, 192. I think this is what went wrong, and then over 6. Can you check your calculation and see where you
Yeah,
went
it's
wrong?
because I had negative 192.
Okay, so that's the trick. Okay, you shouldn't be able to do the square root of a negative anyway, so that would be a giveaway. So anyway, we have minus 2 plus or minus the square root of 196, which is 14 over 6. Yeah. And then have a go at simplifying.
So it would be 2 or 16 over 6.
Good. And could you just verify that that works by putting it back into the very original equation?
Yeah. Yeah, 2 works, and then yeah.
Yeah. Okay. So then, yeah, two will work in that case. So let's talk about this one. So first, it doesn't look like a quadratic, but when you multiply up by the denominators, you should see, okay, I'm going to be multiplying up by x, and I'm going to be multiplying up again by something else involving x. So we've got this multiplication of x by twice, so it must be quadratic. Now, you can solve it with the quadratic formula. You can also solve it with completing the square. I can't remember how much time I spent on this technique, if at all. So I'm just going to start explaining it to you, and then you're going to tell me whether you have any recollection of us doing it. So what you do is you do 3 times negative 16. Yeah, on this side, you do 3 times negative 16. And that gets you negative 48. And then what we need to do is we need to find, just like before when we factorize it, you need to find 2 numbers that multiply to make negative 48, but add together to make 2. So let's try and think of the factors of negative 48. Negative 1 and 48.
Yep.
Negative 2 and 24. Negative 4 times 12. Oh, sorry, I missed one. Negative 3 times 16. Yeah. Clearly these are a bit too far apart, so we can go a bit further. And so we get to negative 6 times by 8. And then we got it. So then what we do is we then write it. We then split it up like this. So this 2, you can now write it as negative 6x plus 8x. Okay. By the way, you could also write it the other way around as plus 8x minus 6x. It actually doesn't matter, and it will never matter. But can you see, like, I took these numbers here and I used them.
Yeah.
to expand this out. Okay, and you're going to see why in a moment. Don't worry. Like if the penny hasn't dropped yet, it's not supposed to happen. Now, can you see how we can factor these things? So what I'd like you to do, could you try your best just to factorize the thing in the red box and then the thing in the green box? You should always find they have a common factor. So have a go at that now.
Okay. It's easier to divide because they're like common multiples.
Yeah, so what's the factor of these on the left? It's 3x, right?
Yeah.
Yeah, x minus 2. Now, what about this one on the right? Plus 8. Yeah. 8
Okay,
times
wait.
what?
2.
X minus 2.
Oh, yeah.
Now, can you see we've got another common factor? And the common factor is x minus 2, right?
Yeah.
So then we can take that out as a common factor. And you end up with x minus 2 times by 3x plus 8. Can you see where the 3x and the 8 come from?
Yeah.
Right? And then you can see one of the solutions is clearly x plus 2, and the other one is negative 8x over 3. Shall we do another one to practice at this?
Sure.
Okay. Actually, no, in fact, I believe there are some in the example. Let's see if there's any. Yeah, let's have a think about this one. Yeah, so if you look in the questions I gave you, yeah, let's just start with that very first one. Okay, 2x squared minus 5x plus 2 equals 0. You can pull exactly the same trick with this.
Are you doing it online? Yeah. He's not coming. No, because then Gabby can watch the recordings. Oh, okay. I was just gonna say that, right? Okay. Sorry.
That's okay. So let's have a look at this. So the first thing you have to do 2 times 2 is you do this times this. 2 times 2, which is going to be 4. So now we need two numbers that multiply to make 4, but add up to make a negative 5. What must they be?
So add up to make 5 and
No,
multiply.
negative 5. Yeah.
Okay.
Yeah.
Well, it'll have to be well, I want to say 4 and 1, but since it's a negative, then
Yeah, you're close.
Mm, negative, negative one.
Remember, they both add up to be negative, so at least one of them is negative. But they multiply to make something positive, so they must both be negative.
Oh, okay. So it's -4 and -1.
Exactly. Okay. So now what we do is we split these to -4x. Okay. Once again, I'm putting the -4x and then -1x this way around. It actually doesn't matter.
Mhm.
Okay, now could you try and factorize? Factorize the first two, and then factorize the second two. Be careful with the negative signs.
Okay. So it would be 2x times x minus 2,
Mm-hmm.
and then 1 times x plus 2.
No, not quite, because there's a negative sign. That's why I said be careful about the negatives.
Okay.
So it's going to be
It would be negative x.
exactly it's going to be -1 times x minus 2. Can you see?
Yeah.
Now, what's the last bit? Once again, we've got this common factor here, this x minus 2. So we can pull it out,
Mm-hmm.
and we are left with x minus 2 times, and then what was left? We've got the 2x
2
and the minus, so we get 2x minus 1 equals 0. Now can you try and solve this?
Mm-hmm. It would be 2 or -1/2.
Yeah. Yep, so either it's 2 or it's a half. And you can verify this by putting this back into the original equation.
Yep.
Okay. Right. Let's have a go at the next one now, which is a little bit trickier. Okay, the next one in the PDF. -3x² plus 7x minus 2. I recommend that you multiply through everything by -1 first.
Mm-hmm. Okay, so you would get 3x minus, 3x times x minus 2,
Mm-hmm.
and then negative 1 times x minus 2.
Yeah, so you're going to get 3x squared. Is it minus 7x plus 2? Yep, equals 0.
Yeah.
And now you multiply the 3 by 2. What
Oh.
did you get?
6.
6. So now we're looking for the two numbers that will multiply to make 6, but add together to make negative 7. What are they?
Negative 6 and negative 1.
Negative 6. Then you end up with 3x squared minus 6x minus 1x plus 2. Notice that's the same second term as we had from before. Be careful with that. So then you end up with 3x times x minus 2 minus 1 times x minus 2
Yep.
equals 0. And then we have 3x minus 1 times x minus 2 equals 0. Therefore, the two solutions are x equals 2 or x equals 1/3.
Yes.
Yep. Okay. Let's just check. Let's just check that the 1/3 works, because it's a bit trickier to see that. So what you'd have to do is you have to put it back into the original equation. So what is 1/3 squared? Well, it would be 1/9, right? So you get 3 times 1/9 minus 7 times 1/3 plus 2 equals 0. So what is 3 times 1/9? Well, it's 1/3 minus 7/3. How many thirds is 2?
Um, how many thirds is 2?
Yeah, how many thirds in 2?
Oh, 6.
Yeah, so 2 is 6/3. And then I think you'll be quite satisfied that 1 plus 6 equals 7 equals 0. So it does work. All right. Let's do one more and then just take a really short break, because we've been going through quite a lot of problems. Can you have a go at doing question 3, please?
Yeah. when I factorized them, I got x plus 1/2. Is that
X plus 1
right?
half. For this last one. So if you have x plus 1 half, then this would mean that x minus a half works. So before you did that, so let's just check. You did 4 times 3, which is 12, and you needed two numbers added together, right, to make 12. So you got two, sorry, that add together to make, yeah, 8. So you got 2 and 6, right? Right?
Yes, yeah.
Yeah, so then you should get 4x squared plus 2x plus 6x plus 3. So I don't think you need to actually expand that far. You shouldn't have a half. You don't need to divide it until you just have 1x. You can leave it. So you have 2x plus 1.
Okay. Well, then how else would you factorize them?
Let's have a look. So you got 4x squared plus 2x plus 6x plus 3. So here you can just factorize this as 2x times 2x plus 1. And then this is just going to be 3 times 2x plus 1.
Okay.
So you didn't need to pull out the factor quite so far. Did you try and divide them by 4 and then by 6, right? Trying to divide the whole thing by whatever the coefficient of x is. Yeah, that's overkill. Sorry, 1 minute, my alarm's just going. Yeah, you don't need to get that far. You won't actually, by the way, get the wrong answer. It's just not necessary. Because you can see in a moment that this is easier to factorize. Because then you just get 2x plus 3. 2x plus 3 times 2x plus 1 equals 0. Okay? And then, if you want, you can do 2x plus 3 equals 0. So in which case x equals negative... sorry, what happened to my whiteboard? X equals negative 3 over 2. Or 2x plus 1 equals 0. Therefore, x equals negative 1 over 2. Okay, all right, let's take a 5-minute break. And then we'll come back and we're going to look at so-called hidden quadratics, which sound really difficult, but they're not. Okay, so it's like once you see it, you see it. Okay? All right, see you in 5. Hi, Olivia there. Yep, you're muted. You are now unmuted. Okay, so let's talk about hidden quadratics. So the idea with a hidden quadratic is it just doesn't look like a quadratic. So a really good example of something like this, like there's like a hidden quadratic, might be something. Maybe something like this. Imagine we had 3x plus 1 squared plus 5 lots of 3x plus 1. plus 4 equals 0. Now, I know this looks somewhat like a quadratic. It's got a square term in it, but it looks like it's still got some work to do, right? Like we need to expand out that 3x squared, and then we need to expand out the 5 times 3x plus 1, and then we need to try and solve it. It's going to be a lot of work, right? First, we're going to have to expand it, collect a load of like terms, and then we have to either factorize it or use the quadratic formula or completing the square. It's a lot of work.
Yeah.
However, we need to look at the big picture. Okay? So what I'm going to say is just have a look at this. This is something squared plus 5 lots of that thing. Okay, I'm deliberately like just using just something visual, right? It's an important thing is that you should just see, no matter what it is, it's something squared plus 5 lots of that thing plus 4 equals 0. Now, can you see this is a quadratic equation?
Yeah.
So what we need to do to make our life easier is we want to break this down into 2 steps. So what we typically do is we make what we call a substitution. So I'm just going to say that y equals 3x plus 1. Okay. Now, this whole thing in that case just becomes y squared plus 5y plus 4. So this is what we talk about like a hidden quadratic. There's a quadratic equation which is hidden inside here. Now, this is quite an easy one to factorize, right?
Yeah.
Could you factorize this for me, please?
Yes. Y plus 4 and y plus 1.
Exactly. So now we know that y is either negative 4 or negative 1.
Yep.
And then let's just do that down the side. So let's do y. If y equals negative 1, and you know that y equals 3x plus 1, sorry, plus 1, could you find out what x is, please?
Yeah. So to find x, would you do like just substitute the 3x plus 1 with negative 1?
No, you don't want to substitute it. You want to create this equation so that 3x plus 1 equals minus 1, and then you can solve it. Right? Like y is just this intermediate step. It's just a placeholder value.
Okay, so x equals negative 2/3.
Yeah, and then you just got to pull the same trick, but now we're going to use fact that y equals -4, and y is still 3x plus 1, right? So you see, y is just this thing that we replace 3x plus 1 with temporarily to help us see and simplify the quadratic.
Yeah. So then this will just be 3x -5/3.
-5/3. There you go. Okay. So do you want to have a look at the questions? Have a look at question 5.
Yeah.
So each of these are a bit different. So have a go at question 1. I know I said we'd be doing something different, but I did just want to put in one logarithm question.
Okay.
So first copy it out and then decide what are you going to call y? Well, it doesn't have to be y, it could be k, or you can just put anything. But what's the thing that you want to replace to make this easier?
I'll replace like y equals log 10 or whatever.
Log 10 of x, yeah, exactly. So then what does
Yeah.
this become? What becomes?
Y squared
Yeah.
minus 2y minus 3.
Good. Now, this should be quite easy to factorize, right?
Yeah. So it'll be y minus 3 and y plus 1.
Good. Okay, so then you have, let's factorize one that's really good. Let's see, y minus 3 and y plus 1 equals 0. So now you know there's two possibilities. And we're going to look at each of them separately. So either y equals 3 or y equals -1. Could you have a go at y equals 3 first?
Yeah. So log 10 of
X equals 3.
Yeah.
So
then,
think about what a logarithm means.
so it's asking 10 to the power of what equals x, right?
10 to the power of what equals x? No, is it? Sorry. What number is, when you take its logarithm, is 3? That's basically what it's saying. So what number is 10 to the power of 3?
Okay. 3, so that's going to be 1,000. But then, like,
it becomes 1,000, exactly.
okay, so you just write 1,000?
Yeah, because if you did log 10 of 1,000 equals 3. Now, this next one, -1, So what number is, when you take the logarithm of it, is -1? So remember, 1,000 is 10 to the power of 3. So this is going to be 10 to the power of,
-1.
yeah, what is 10 to the power of -1 as a fraction?
1 over n squared.
No, because that would be to the -1. That would be to the -2. This is just 1 over 10. 1 over 10 to the -1. It's going to be 10 to the -1. Okay, so then this one's going to be 10 to the 3. So notice this, by the way, when you do the quadratic equation, you always get a branching off. Yeah, you always get a branching off into 2 branches at least, providing the solutions aren't the same. And then sometimes both of those branches will then work out. But can you see that we use the hidden quadratic to find those 2 branches, and then once we have those 2 branches, we solve the equation separately. Let's have a look at this next one. Okay, sine squared of x minus sine x plus 4.
Okay. So I'm going to replace sine of x with y.
Yeah, good.
So then it'll just be y squared plus y plus 1/4 equals 0.
Exactly, yeah.
Okay, but that's
So 2 numbers that will add together to make -1, but multiply together to make a quarter.
-1.
Yeah, they add to make -1, but multiply to make a quarter.
Okay. Um, 2 halves.
It's going to be a half.
Yeah.
So you're going to end up with y minus a half, just squared, right? Equals 0.
Okay.
So now what do you know y equals?
A half.
Good. So if y equals a half, and then we can replace y with sine x, then we end up with sine x equals a half. And then you can use your calculator if you can't remember this one.
Okay. I have trouble finding it. Sorry, I don't know where my calculator is.
Okay. All right. Just in the interest of showing you, okay.
Yeah.
That if you think about what like a sine graph looks like, if you've got the axes, the sine graph looks like this. Goes up, and then it goes down. And we're looking at for when it's a half. So it's a half at 30 degrees, And then by symmetry, it's also half 150 degrees.
Okay.
This is 150 degrees. So notice, by the way, that sine between 0 and 360 will always have two solutions. Therefore, if you have a quadratic equation, each solution itself gives birth to two solutions. So can you see how this one, the quadratic only had one solution, but that solution still gave birth to 30 and 150? If we'd had one like this would be the last one we do. Imagine we'd done, let's imagine we did sine squared x. And let's think, okay, these are a bit hard to do because they have to be fractions. Nonetheless, let's do 3/4, negative 3/4, sine x, or sine x. And then what's half? Plus an 8. Equals 0. If we use the substitution, we get y squared minus 3/4 y plus an 8. You need two numbers that multiply together to make an 8, but add together to make 3/4. I'll just tell you what they are if you haven't got them. One of them is negative a half, and one of them is negative a quarter. Now, can you see that we're going to get two solutions? Get y equals a half, which we just did, and also y equals a quarter. Now, each of those is then going to produce, when you do the inverse sine, is going to produce 2. So this problem is going to have 4 solutions, because you get this branching in the quadratic equation. The quadratic equation produces 2 solutions, and then each one of those solutions, when you do the inverse sine, produces 2 as well. So these get quite messy.
Yeah.
So you have to be very, very diligent. Yeah. Okay. Any questions there?
Wait, what do you mean? Because like the answers would be y equals a half and y equals a quarter, right?
Yeah, exactly. But then remember, y is actually sine x. So then you end up with this sine x equals a quarter, and sine x equals a half. And that has 2 solutions.
Got it.
So you're going to end up with 4 solutions in general. So let's have a very, very quick recap. Not all quadratics look like quadratics. So let's just go through to the beginning. Things like this. All right. Sometimes you need to do some manipulation until things look like quadratics. In general, you have to do this because in real life, real life is not when I say real life, I just mean like naturally occurring math problems and not like a textbook. So it might look like it this way, but then you might need to rearrange it to make it a quadratic like this one. Okay, you had to multiply by both denominators. Generally though, once you get everything on the same level, once you get rid of any unknowns and fractions, and then you collect like terms, move everything over to one side, then it should be clear whether something's a quadratic or not. But yeah, just get used to the fact that some things aren't quadratics. Here, be very careful about negative signs in the negative for AC. You're not the first student to have difficulty with this. You won't be the last. But just be careful. Okay, negative signs are probably the biggest cause of mistakes for everybody. Okay? Here, we practice this. Right, I mean, I introduced how to do this, how to factorize. It's not always possible, but when a is greater than 1, sometimes it's possible to factorize. It's just like normal factorization with a couple more steps. You need to multiply a by c, and then you need to try and find the numbers that add up to make that, and then you do this like kind of two-step factorization. And then we did a bunch of that, and then you got quite good at that. And then the last thing is hidden quadratic. So whenever you have something squared plus some lot of that thing plus a constant equals 0, if you can get something in that form, then it is a quadratic. So first, what we typically relabel it as y. It doesn't have to be y, right? If they're already using y, of course, you have to use another relabeling. But you relabel it something. You solve the quadratic first, and then once you have the solutions to the quadratics, you treat them separately. Like we've got the y equals 3 and the y equals -1. Or here, when we have the sine x equals a half and sine x equals a quarter, that's what you do. Okay? And that is a wrap. I will see you next week. All right, take
Thank you.
care. Bye-bye.
Bye.